Hello and welcome to NEPTEL classes. Today I am here to solve chemistry class 11th NCERT problem 2.55 from unit 2nd, that is structure of atom. In the problem it is mentioned that emission transition occurs in Paschen series, and for this emission and during this emission transition electron is returning from higher energy orbit n to lower energy orbit n is equal to 3, and if the transition is represented like this, that frequency of transition is equal to 3.29 into 10 to the power 15 1 by 3 square minus 1 by n square in hertz. We have to calculate value of higher energy orbit n, from which electron returns to n is equal to 3. If the transition is observed at 1285 nanometer wavelength. So we have this emission transition is represented like this, that frequency of transition is equal to 3.29 into 10 to the power 15 hertz 1 by 3 square minus 1 by n square. It is also given that transition is observed at wavelength 1285 nanometer. I mean radiation emitted as a result of this emission transition when electron returns from higher energy orbit n to lower energy orbit n is equal to 3 has wavelength equal to 1285 nanometer, and its frequency is given by this expression. Now we have to calculate value of n. We have to determine value of higher energy orbit from which electron is returning, and we have to find out. Idea is that velocity of electromagnetic radiation is related with its frequency and wavelength. C is equal to nu lambda, and here using this equation I will use this equation in order to express this wavelength of radiation in terms of frequency. So frequency I will get is equal to C divided by lambda. Now I will substitute value of C, velocity of light in vacuum. It is 3 into 10 to the power 8 meter per second. Wavelength is given 1285 in nanometer, and in meters it will be 10 raised to the power minus 9. And after evaluating, frequency comes equal to 2.3 into 10 to the power 14 hertz. So idea was to express wavelength of radiation in terms of frequency, and now I can substitute this value of frequency here. Frequency I got 2.3 into 10 to the power 14 is equal to 3.29. I will write here. Instead of frequency, if this is equation first, In equation first I will substitute the value of frequency now equal to 2.3 into 10 to the power 14 is equal to, this value is in hertz, is equal to 3.29 into 10 to the power 15 1 by 3 square minus 1 by n square. It will come equal 2.3 into 10 to the power 14 divided by 3.29 into 10 to the power 15 is equal to 1 by 9 minus 1 by n square. And after evaluating, LHS side comes equal to 0.069 is equal to, this will become n square minus 9 divided by 9 n square. Here I will get n square minus 9 is equal to 0.069 multiplied by 9 n square, and it comes equal to n square minus 9 is equal to 0.621 n square. N square I will take on one side, I will take this here, it will come n square minus 0.621 n square is equal to 9, and it comes, I will take n square common, 1 minus 0.621 is equal to 9, and it comes 0.371 into n square is equal to 9, and n square will be equal to 9 divided by 0.371, and n will come equal to 5. N will come equal to 4.9, approximately equal to 5. So for this transition, for emission transition, N1 is 3, N2 is 5. Since lower energy orbit is 3, lies in Paschen series, and will lie in infrared Paschen series, and it will in the spectrum it will be second line in Paschen series. For first line N2 will be 4, N1 will be 3, and for second line N2 is 5, N1 is 3, second line, and will lie in what region? IR region, infrared region. Let me recall. In the question it was given that we have an emission transition, and during this emission transition electron returns from higher energy orbit n to lower energy orbit n is equal to 3. Question says that this emission transition lies in Paschen series. Electron is returning from higher energy orbit n to lower energy orbit 3. This transition is represented by this equation, which gives frequency of transition in hertz equal to 3.29 into 10 to the power 15 1 by 3 square minus 1 by n square. Now we have to find the value of lower energy orbit. Now we have to find the value of higher energy orbit n, from which electron transition occurs. In the question, wavelength of radiation emitted during the transition is given 1285 nanometer. Now I need to determine the higher energy orbit n from which electron transition occurs, from which emission transition starts. Idea is that I will express this given value of wavelength in frequency. For that I will use this equation, that velocity is equal to product of velocity of electromagnetic radiation is equal to product of frequency and wavelength. From here I will get frequency is the ratio of velocity of electromagnetic radiation and wavelength. Velocity of electromagnetic radiation is constant 3 into 10 to the power 8 meter per second. Wavelength was given 1285 nanometer. I expressed it in terms of meters. Frequency of radiation emitted in this emission transition, I got 2.3 into 10 to the power 14 hertz. I substituted this value of frequency in equation first, and after solving equation first, I got that value of higher energy orbit from which electron transition occurs is n is equal to 5. So for this emission transition, lower energy orbit is 3, higher energy orbit is 5. So transition lies in emission series, and it represents second line of Paschen transition lies in Paschen series, and it represents second line of Paschen series and lies in infrared region of the electromagnetic spectrum. Class 11th students, this is the problem I have got for you today. See you day after tomorrow, as tomorrow is reserved for class 12 students. Allah Hafiz.